Hello and welcome to this lesson with a further introduction into material design. In this lesson, we'll take a deeper look into the material design visual language and standards. Although material design was introduced with Android 5.0, Lollipop, API version 21, some of the features and components of material design are available for earlier versions of Android through the Android support libraries. The tangible surface created through material design should communicate to the user a layer of pieces of digital paper. Shadows are used to communicate which surfaces are in front of others, helping focus attention and establish hierarchy. Shadows and surfaces are used in a consistent and structured way. Each shadow indicates a new surface. Surfaces are created thoughtfully and carefully. There are generally between 2 and 10 surfaces on the screen at once. Avoid too much layering and nesting of surfaces. Scrollable content either scrolls to the edge of the screen or behind another surface that casts a shadow over the content surface. Never clip an element against an invisible edge. Elements don't just scroll off into nowhere. Put another way, you rarely scroll the ink on a surface, you scroll the surface itself. And as we see here, an animation example of the different layers in a material design screen. Apps use a primary color and an accent color, as we see here in the example on the left, to color surface backgrounds and key UI widgets such as text fields and checkboxes. The accent color contrasts very well with the primary color. For example, an app can use a dark blue primary color and a neon pink accent color, as we see here in the example for the Fab or floating action button in pink and the title in dark blue. The accent color should be high contrast and should be used to call attention to key UI elements, like a circular floating action button, selected tab strips, or form fields. In the left example, we see the primary blue color used for the app bar section and title of the activity, and the pink accent color used for the floating action button in order to accent it against the primary color. Icons, photos, images, text, and other foreground elements are colored ink on their surfaces. They don't have shadows and don't use gradients. Colors extracted from images can be used to color adjacent UI elements or surfaces. In code, this can be done by using the palette support library. Photos are generally immersive and full bleed. For example, in a detail screen, run the picture edge to edge and it can never appear behind the app bar or status bar. You can see an example of this in the example on the right, a view with a photo in the top app bar section, running from edge to edge, including under the status bar, which has been made transparent so that it will not be seen behind it. UI elements should be aligned to and sized according to an 8dp baseline grid. For example, app bars are 56 dp tall on phones and 64 dp tall on tablets. Padding and margins can take on values like 8dp, 16dp, 24dp, etc. More precise text positioning uses a 4dp grid. In general, UI and content elements don't just appear or disappear. They animate into place, either together, as a unit, or individually. There are several types of animations and motions in order to convey visual feedback to the user. When touching an item to see its details, there can be a hero transition, which we can see here in this animated example, that moves and scales the item between its position in the browsing screen and its position in the detail screen. Ripple effects originating from where you touch the screen are used to show touch feedback on an item. UI elements can also appear using a circular reveal animation. Animations can also be used in more subtle, delicate ways, such as to convey the transition between icon states or text states. For example, a plus icon can morph into an X symbol, or an outlined heart icon can be filled using a paint bucket fill effect. Animations and transitions are fast, generally under 300 milliseconds. Applications use responsive design best practices to ensure screens lay themselves out appropriately on any screen size and in any orientation. Detail screens are often presented as pop-ups that appear using hero transitions. In multi-pane layouts, the app can use multiple toolbars to place actions contextually next to their related content. Where appropriate, an application should promote the key action on a screen by using a circular floating action button, or FAB. The FAB, as seen here in red, is a circular surface, so it casts a shadow. It is colored with bright accent colors. It performs a primary action such as send, compose, create, add, or search. It also floats in front of all other surfaces and is normally at an 8 dp elevation. It frequently appears at the bottom right of the screen or centered on an edge where two surfaces meet at a seam or step. Applications should use a standard Android app bar. The app bar doesn't have an app icon, but color and typography are used for branding instead. The app bar casts a shadow or has a shadow cast on it by a surface below or behind it. The app bar normally has a 4 dp elevation. In code, use the new toolbar widget in Android 5.0 that is placed directly into the Activities view hierarchy. AppCompat library also provides a toolbar which supports all modern platform versions. Some characteristics of the app bar are that it can be collapsible from an enlarged size of 2 to 3 times the collapsible size upon user scrolling. It can also be transparent in order to overlay the text and actions of the app bar upon an image. And it can be scrolled off and on the screen when scrolling down or back to the top respectively. Tabs should follow the newer material design interactions and styling, as seen here in the example on the left. If the app uses top-level tabs, tabs are visually a part of the app bar. Tabs are a part of the app bar surface as well. Tabs should support a swipe gesture for moving between them. If the app uses a navigation drawer, it should follow the newer material design interactions and styling, as seen here in the example on the right. In code, you can implement drawers using the Drawer Layout widget from the support library, along with a new toolbar widget. The leftmost icon in the app bar is a navigation drawer indicator. The app icon is not visible in the app bar. The drawer is a standard width, no wider than 320 dp on phones and 400 dp on tablets, but no narrower than the screen width minus the standard toolbar height. Item heights in the drawer follow the baseline grid of 48 dp tall rows, 8 dp above list sections, and 8 dp above and below dividers. Here we see an example of using a material design theme in an application. Note that the material theme is only available in Android 5.0, API level 21 and above. The V7 support libraries provide themes with material design styles for some widgets and support for customizing the color palette. In this example, we can create a theme for the application based off the material design theme in Android and customize it for our needs. Material design introduces elevation for UI elements. Elevation helps users understand the relative importance of each element and focus their attention to the task at hand. The elevation of a view represented by the Z property determines the visual appearance of its shadows. Views with higher Z values cast larger, softer shadows. Views with higher Z values occlude views of lower Z values. However, the Z value of a view does not affect the view's size. Shadows are drawn by the parent of the elevated view, and thus subject to standard view clipping, clipped by the parent by default. The bounds of a view's background drawable determine the default shape of its shadow. Outlines represent the outer shape of a graphics object and define the ripple area for touch feedback. Clipping views enables you to easily change the shape of a view. You can clip views for consistency with other design elements, or to change the shape of a view in response to user input. Motion in the world of material design is not only beautiful, it builds meaning about the spatial relationship, functionality, and intention of the system. Physical objects have mass and move only when forces are applied to them. As we see here in this example, objects should accelerate swiftly and decelerate slowly to allow motion that feels natural and delightful to the user. Animations in material design give users feedback on their actions and provide visual continuity as users interact with your app. The material theme provides some default animation for buttons and activity transitions, and Android 5.0 API level 21 and above lets you customize these animations and create new ones. Touch feedback in material design provides an instantaneous visual confirmation at the point of contact when users can interact with UI elements. Reveal animations provide users visual continuity when you show or hide a group of UI elements, like the circular reveal animation to animate a clipping circle to reveal or hide a view. Activity transitions in material design apps provide visual connections between different states through motion and transformations between common elements. You can specify custom animations for the entering and exiting of transitions for shared elements between activities. Animations in material design rely on curves for time interpolation and spatial movement patterns. ViewStat change animations can be used for a variety of purposes in material design, like animating changes of specific attributes of a view on change or the view state. Here we see an example of utilizing activity transition animations in code. In the button callback named OnSomeButtonClicked, we want to start a new activity, but we want to use an explode transition for animating out of this current activity. We set the exit transition by calling the setAxisTransition method on the current window. We then create the intent for a new activity and start it with the activity options, which will create the desired transition animation. In this example, we get a specific view with ID MyView, and we set a reveal animation on it by creating a circular reveal animator. Once the reveal animator has been created with our calculated centers and radius, we set the view to visible and start the animation upon it as desired. In addition to new features with animations, transitions, and colors in material design, we also have new features on Drawable class with the release of Android 5.0 API 21. These include features like drawable tinting, where we can tint bitmaps, and patches defined as alpha masks. To add to the new color properties and design aspects, we can also extract colors from images by utilizing the palette class available in the Android support library. The palette class can allow us to extract prominent colors with different flavors like vibrant dark, vibrant light, muted, and more. Another addition in API level 21 is allowing for the definition of vector drawables that allow for scaling without losing definition. Some material design features, like the material theme and custom activity transitions, are only available in Android 5.0 API level 21 and above. However, some others are available through the support library for previous versions of Android. You can configure your app to use material theme on devices that support it, and revert to an older theme on devices running earlier versions of Android. By allowing these alternative style definitions, you can still utilize the material design styling on application devices running the appropriate version of Android. If the layouts that you design according to the material design guidelines do not use any of the new XML attributes introduced in Android 5.0, then they should work on previous versions of Android as desired. Otherwise, you can provide alternative layouts for previous versions of Android. The V7 Android Support Library Revision 21 and above includes some material design features that can be used for previous versions of Android, including some material design styles, color palette theme attributes, the Recycler View class, the Card View class, and the Palette class. Thank you for joining us in this deeper introduction into material design. Join us in our next lesson where we'll take a look at the Card View and Recycler View classes.